Alrighty then. 3.3, proofs with parallel lines. Proofs with parallel lines. So the last time we met, this is the stuff we talked about. Last time we said, if these two lines are parallel, then the corresponding angles are congruent. Again, if the lines are parallel, then the alternate interior angles will be congruent. If the lines are parallel, then the alternate exterior angles would be congruent. If these two lines are parallel, then the consecutive interior angles are supplementary. Okay? In that case, we started off with the lines are parallel, then something else occurs. This time, we're doing the converse. Converse, I mean, we actually have to use the stuff we had before? What? So this time, we're going to say, here's a bunch of lines. This line's your transversal, and we're going to state that these two angles, angle 4 and 5, are corresponding angles. If these two angles are congruent, then these two lines will be parallel. So if corresponding angles are congruent, then the lines are parallel. Okay? And then there's another one that says alternate interior angles. If angle 3 and angle 6, since these are alternate interior angles, if the alternate interior angles are congruent, then the lines are parallel. Same thing with alternate exterior. If alternate exterior angles are congruent, then these lines are parallel. And the last one, if consecutive interior angles are supplementary, then these two lines are parallel. Okay? So it's just a converse of what we did last time. It's just a converse of what we did last time. So here's some examples. Let's do examples. So this is A3. This is going to be something similar to question 3. Find the value of x that makes these two lines parallel. Okay. Well, look at this. We have these two angles. These are corresponding angles. And if corresponding angles are congruent, then these two lines are parallel. So we have to make these two angles congruent. So we say 135 is equal to 3x. And then we use our handy dandy calculator. It's all right. Then we use the algebra. Divide by 3, divide by 3. X equals 45? 45 degrees. So if x equals 45 degrees, that means this angle and this angle are congruent. And if the corresponding angles are congruent, that means these two lines are parallel. Done. Okay. Let's do this one. This one is going to be similar. This is B5. This is similar to question number 5. What would you have to do to show that these lines are parallel? Well, we look at these two angles and these two angles. If you remember what we're looking at, this stuff right here. Angle 3 and angle 5 are consecutive interior angles. These two angles are consecutive interior angles. Well, if those two angles are supplementary, let's put it right here, 142. If these are supplementary, 3x minus 13. If this plus this equals 180, if that's true, then these two lines are parallel. So we just have to find a value of x that makes this a true statement. The hard part is setting it up. The rest of this is algebra. Okay. Combine like terms. These and these are like terms. That's 129 plus 3x equals 180. And then, my calculator is this phone. Subtract 129 on both sides of the equation. 3051 divide both sides by 3, and x equals 17, 20, 1, 2, 3, 17. So x is 17. If x is 17, that makes these two angles supplementary, which means these two lines are parallel. Boom! Number 12. Hold on, let me get on the other side of the equation. Oh, 21. Here's 21. Question 21. Can we see this on the paper? Scooch that down. There we go. On question 21, it states, if these two lines are parallel, given this information, if that's 123 degrees and that's 57 degrees, would these two lines be parallel? This is really similar to question 21. Okay, actually this is 21. This is 21, what am I talking about? It's similar. It is. Okay. If that's 57, these are form a linear pair. So this plus this, let's call this x. These form a linear pair, so 57 plus x equals 180. Subtract 57 on both sides. X equals 131.23. So that's 123 degrees. So now we're saying that angle and that angle are corresponding angles. And since the corresponding angles are congruent, that makes these two lines parallel. Boom! Okay. Now let's go ahead and do, where's numbers? I had a piece of paper. Number 12. I don't have it. Well, just have to do it from scratch. 12. In exercises 11 and 12, prove the theorem, consecutive interior angles converse theorem. 3.8. So, converse theorem. Here's 3.8 right here. It's on page 139. If two lines are cut by a transversal, so the consecutive interior angles are supplementary, then the lines are parallel. So if angle 3 and angle 5 are supplementary, then line J and line K are parallel. Okay, it's on page 139. So we have, and let's call this A and B. Okay, we're given A plus B equals 180. It's given. It says if their interior angles are supplementary, okay, that part's given. A plus B is 180. I'm going to introduce, here's an angle right here, C. B plus C are form a linear pair. B plus C are also supplementary because they're a linear pair. Or B plus C, because the definition of a linear pair are two angles that are adjacent and supplementary. So definition of linear pair. Okay, linear pair are two angles whose sum is 180 degrees and the angles are adjacent. Okay, so wait a minute. If A plus B is 180 and 180 equals 180 and 180 equals that, therefore A plus B equals B plus C. You can use transitive, or you can use substitution. I don't care which one you use. Substitution. If A plus B equals B plus... what if we subtract b on both sides of the equation? We get a equals c. How do we do that? It rhymes with subtraction. Oh, subtraction. Subtraction property. A equals c. Well, wait a minute. If a equals c, wait a minute. These are corresponding. If a equals c, that means, what does this do? We'll call this L and P. If A equals C, that means corresponding angles are congruent. That means line L, and line P are parallel because corresponding angles are congruent. So line L is, I'll show you, parallel to line P, line L and line P, because of corresponding angle. So if the corresponding, sorry, bring it down here. If the corresponding angles are congruent, then the lines are parallel. This is the corresponding angles converse theorem. Boom, done. So line L is parallel to line P. Man, that was not easy. Ugh. Ugh. Okay, so once again, this was 3.3 proofs with parallel lines. So you're gonna have to do some work here. This one's not easy. The proofs are not easy. Proofs are never easy. Okay, see you next time. Bye, guys.